In FeatureCAM 2013, modifications have been made to the tool axis definitions. In this example we have a cavity part, and we're going to run a series of toolpaths inside this using some of our new 5-axis options. First thing I want to do though is I'm going to select all of these operations. I'm going to exclude those from the plan and just do my initial roughing, and also doing some 2.5D clearance operations on the top of one of these bosses. I'm going to go to my view, simulation, I'm going to clear the starting point and then play my 3D simulation to remove that initial material. So we have some roughing, we have a small amount of rest roughing, and then the 2.5D operations around one of the bosses. I can now save that as my starting point. These operations can now be hidden, and I can start looking at the finishing operations. First one I want to look at is this parallel finishing in a vertical orientation. If I do a centerline simulation, move the tool to position. If I rotate the view round, you can see the tool is currently orientated vertically. This gives us a nice toolpath, but unfortunately when we do a 3D simulation you'll see we get a gouge on our part. If I turn off the gouging and gouge checking, you can see this is down to the holder. If I play the simulation, you can see the tool holder is colliding quite a lot with the part. So I need to do some kind of reorientation of the tool in order to be able to machine this component. Let's look at these side areas first of all. So here you can see I'm going to orientate the tool over using a lead-lean orientation. So the idea here, if I view from the back of the part, I want to orientate normal to this surface. In previous versions of FeatureCAM, for example 2012, if I go ahead and create or orientate the toolpath, you can see the tool still appears to be vertical. If we look at the toolpath into the 5-axis, you can see I'm using lead lean, and I've set a 0 angle for both the lead and lean positions. However, it is the method that we're using which is causing this issue. We have several new options. At the moment we're using the legacy option. So the legacy replicates what we did in 2012. The problem with the 2012 orientation is the orientation of the tool is calculated at the preview frame stage. This is a hidden stage during the toolpath calculation which generates an initial preview of the toolpath before projecting the toolpath down onto the part. If I actually look at the preview frame, and in this case I'm going to open a layer called preview frame, so this just gives you an indication as to where the tool axis is initially calculated. Here you can see we effectively calculate the toolpath on the top face of the block and then project this down. It was at this stage that the tool axis was calculated. The improvement to this, if I go into the parallel toolpath, into the 5-axis, this time we're using the contact normal. So we've improved upon the toolpath type by using the same lead lean angle, only this time we're using the contact normal of the surface and not the preview projected frame. If I play centerline simulation, you can see the tool is already indexed over. If I use my Alt F3, you can see the tool orientation is now normal to that face as we wished. Continuing this playing through, you can see the tool reorientates for this side as well. If we do this as a as a 3D simulation, play that through, we no longer have a holder collision. However, this isn't ideal because we've only managed to machine these smaller regions at the side. If we use lead lean and continue on this face, we have a problem here where we've got this fillet region, and we'll switch to vertical in a very short distance. So we're going to change the strategy. So using the same parallel finish, only this time we're using towards a line. We've got this line selected, and again if I go into the parallel toolpath, into the 5-axis tab, you can see I've got from a line, and in this case I'm using the old style. So this is the 2012 orientation. Again, if I do centerline simulation, single step, let's look at the back of the part. And again, doing an Alt F3, you can see the toolpath, or the tool orientation, seems to be tilted a lot further over. We're not actually going through this line. And again, this is down to the fact that the tool axis was originally calculated at the preview frame stage. If I continue to play this through, the tool is tilted over by quite an extent. If I look at this as a 3D simulation and play this through, we still appear to be clear of any collisions. However, let's look at this on the machine. In this case I'm using a Hermler C30. Play this, and we're getting a collision indication because we're tilting the tool too far over. We can verify this by turning our collision checking back on. So here you can see we've got a collision, and we can quite clearly see that the spindle has actually collided with our part. So again, the new option, go into our 5-axis tab. So again I've got from line, this time using the new calculation method. Again, if I do a centerline simulation, look from this position, now we can see the tool is passing through that line as we would have expected. This makes it much easier to predict what the tool orientation will be like when we get on the machine. If I go ahead, place as a 3D simulation, there's still no gouges or collisions from the 3D view, but if we do this as a machine simulation, we can re-verify to make sure that we're clear of the part and that the spindle doesn't collide. So we now have a collision-free toolpath. The final one we have is a couple of flow line type toolpaths. So again, just highlighting, these use a flow line reference surface. If we look at the first toolpath and do a centerline simulation, so we're using a tool axis, and again we're using a line, but again we can see the issue because the toolpath axis is created based on the flow line reference surface, not on the surfaces we are projecting to. we play that through, we can see the tool was orientated incorrectly. If we did that as a machine simulation, and again play that through, you can see the tool has collided with the material. And again, this is because the tool orientation is incorrect. If we use the new method, and again from a line, using that line orientation, and again I do a center line, the tool now appears to be tilted over in the correct orientation. We can re-verify that on the machine. Playing that through and making sure that we have no collisions on our passes.